GRHA WIKSA Praniti is a green building prototype built by a research institute for housing and human settlements as a medium to apply settlements and housing technologies, and as a living laboratory for testing new technology as well. Work and housing of Indonesia. The application of technologies from research and development on GRHA WIKSA Praniti is a part of a distinctive contribution towards replicative green building design principles and technologies. These applications are categorized as site modification, building orientation, passive cooling design on building facade, and surface utilities. GRHA WIKSA Praniti features adaptive thermal comfort capability through natural ventilation without the use of active conditioning system. Water conservation. Water efficiency efforts are implemented with the development of water-saving plumbing system, utilization of rainwater, rainwater retention, replenishing groundwater, and recycling wastewater. GWP landscape are optimized as part of wastewater treatment facility with bio-phytofiltration means, and rainwater harvesting with sub-reservoir tanks. Drinking water and clean water provided on the building have been using combination of rainwater and groundwater as sources. Utilization of rainwater harvesting from roof, local drainage system, and catchment wells contribute to 80% of water retention and 20% of groundwater replenishment. Processing of those water sources with granular multimedia filtration system and low-pressure membrane filtration system are needed. Waste management with 3R concept: reduce, reuse, and recycle. These facilities are designed with a distinct label, color-coded red, hazardous, green, organic, yellow, unorganic, and enclosed container. Any organic waste such as leftover meeting foods will be processed with 2 composters, operated alternately. Lighting system. Utilizing natural illumination, skylighting from various orientation, natural illumination optimization through high-ratio transparent surface room lighting are designed to use natural illumination at noon, and if the light conditions are less than standard lux, then artificial lighting could be added. At nighttime, whenever the main hall of GWP is used for meeting or exhibition, artificial lighting are utilized. If GRHA WIKSA Praniti is not being used, lighting system will utilize energy collected from photovoltaic or solar cell specifically for facade area and outside corridor on the ground floor. Ventilation system. GRHA WIKSA Praniti is not equipped with air conditioning system. In favor of natural wind flow for transferring heat from indoor to outside through convection means, this condition creates thermal comfort by using wind flow generating from windows or ventilation openings. Fenestration on the building are designed to maximize wind flow to avoid the energy used from air conditioning system. These fenestration are found on west and east surface in form of jalousie louvre window located both at 60 cm weight from floor and 240 cm height. In turn, this louvre window configuration will create cross-ventilation effect for cooling purposes. Maintenance and management. As GRHA WIKSA Praniti aim to utilize passive design without relying on active energy management system, standard operating procedure related to technologies and building maintenance. Daily operational maintenance procedures are being conducted by 5 maintenance workers outsourced from private sector building maintenance and operation firm. One of the standard operating procedure regulates the water conservation system inspection procedure for GWP. Wastewater management. Implementation of water-saving plumbing system on GRHA WIKSA Praniti leads to daily water usage of 20 liters per person. This plumbing system applied to less than 6 LPF for water closet, less than 3.8 LPF for urinal, less than 2 liters per person for faucets. Wastewater management considers maximum capacity times daily wastewater produced of 16 liters per person to determine peak factor. The wastewater management consists of equalizer unit, anaerobic biofilter unit, and media-based artificial wetland. Processed wastewater have followed regulation of Indonesia quality standard and can be used for watering plants, cleaning the building, or to be used for fish pond. Conclusion: GRHA WIKSA PRANITI, which is located in Bandung, West Java, Indonesia, is the building for Research Institute of Housing and Human Settlement, Ministry of Public Works and Housing, with the age of building 8 years. GWP landscape consists of soft space to absorb solar radiation and permeable hard space that able to replenish groundwater. Microclimate being controlled by green facade and green wall, energy efficiency with the use of photovoltaic, zero runoff with ground reservoir, and wastewater management with filtration system. Lighting fixtures, LED lamps and photovoltaic lamps. Lighting load, 4.79 watt per meter square, gross floor area. Building air conditioner system and equipment. Fresh air exchange rate, 0 meter per cubic per hour per person. 0 meter cubic per hour per meter square, 0 per meter cubic per hour. Energy efficiency of aircon chiller, 0 kilowatt per ton. Cooling load, 0 watt per meter square, air conditioned area. Energy consumption. While the value of the energy consumption index in the GWP building with an area of 3,200 meter square is 12.61 kilowatt hour per meter square per year, if the AC room server and central quake server are eliminated, then the value of energy consumption index become 8.2 kilowatt hour per meter square per year, while energy used monthly is 3,589 kilowatt hour. Environmental impacts. Impacts of waste. Wastewater management are using eco-friendly biofuel tank. Any runoff will be distributed to media-based artificial wetland and further distributed into catchment wells. Impacts of pollution: air, noise, visual, exhaust, etc. Good overall indoor air quality due to passive design allow natural wind flow and absence of active air conditioning. No smoking rule are in effect despite lack of indoor smoking area. Cross ventilation generated by placements of louvre windows on west and east side of the building.